Number two, we can transfer energy in three different ways. We can transfer by working, we can transfer by heating, and we can transfer by radiating. Well, working is going to be for big objects. For example, in the Bill Nye video, when he pushes the bowling ball against the window, the bowling ball works on the window. A pushing force is pushed into the window, and that would be an energy transfer via working. Q is heating, and that's going to be for particles. So when particles are moving at different speeds or moving at different arrangements, that's going to be caused by heating. And radiating is R, and that's for light. So I didn't put this. W is working, Q is heating, and R is radiating. Working is for big objects, heating is for particle motion, and radiating is via light. Number three, draw a heating curve for a substance that melts at 15 degrees and boils at 85. I'm just going to do a quick sketch here like this. Well, this should be a plateau. This first plateau here is our melting point, and so we're just going to call this 15 degrees Celsius. The second plateau is our boiling point, so we'll call that 85 degrees Celsius. So this is our temperature, and this is our time. Guys, this comes from your icy hot lab, although in your icy hot lab we were using water, so our first plateau was at 0 degrees Celsius, and our second plateau was at 100 degrees Celsius, boiling temperature for water. Include the following labels. Time, got it. Temperature, got it. Solid would be here on this first plateau. Liquid would be here on the second plateau. So this incline. Solid's on the first incline. Liquid is on the second incline. This plateau here is where you have solid and liquid because you're melting. So we've got solid, liquid. Gas is going to be here. Now, there is some gas here on this plateau, but that's where it's boiling. So it's liquid turning into gas. And then technically there would be another incline here as well, and that's where it would just be gas. Now thermal energy is going to be absorbed anywhere where the temperature is increasing. Remember, thermal energy is all about the speed of particles. So we've got this hot plate, it's putting out a bunch of energy, and that energy can be stored in different ways. For example, here the temperature is changing, which means that the thermal energy is increasing here. Here, the temperature is increasing, which means that the thermal energy is increasing. And here, thermal energy is increasing. Now these plateaus, the beaker is still on the hot plate, but the temperature is not going up. And I talk about this all the time. Students call me over and say, I think my thermometer is broken. It's sitting here on the hot plate, but the temperature is not increasing. And so, that's true. What happens is that the energy coming from the hot plate is stored as phase energy. So this energy doesn't go to speed up the particles, it goes to spread out the particles. And so this is phase energy, and this plateau, phase energy, is being stored as well. Okay, fantastic. Number four, this time it's a cooling curve. And so I like to do it backwards, actually. It's a heating curve. Okay. A substance that condenses, vocabulary word, from gas to liquid at 64 degrees. Hey, here's our gas. Here's our liquid. So this is the point at which it condenses. So this is 64 degrees Celsius. And freezes at 10 degrees. Here at our second, freezes, remember, is going from liquid to solid. So this would be the point at which it freezes. And so this, of course, would be our temperature. This would be our time. So got that and that. Solid, got it. Liquid, gas. Thermal energy is going to be here at this incline, then at this incline. Now let's imagine that we were able to capture all of the gas that was being boiled off and then continue heating it up. Well, then the temperature would increase here. Remember, because those hot plates go to 550. So if we have liquid on there, with water at least, it could only go to 100. With this chemical, it's only going to go to 64. But if we were able to boil it off and capture that gas in a bag or something, then we could set that bag and continue to heat it up, and it would go hot, hot, hot. So thermal energy is there, and phase energy would be here and here. Number 5, money accounts are a good metaphor to help us understand energy storage and transfer. Describe the way money accounts are like energy. Well, remember back to this story. Imagine you have $1 underneath your bed. You wake up in the morning and you decide, I'm going to spend this $1 today. So you transfer that $1 from underneath your bed to your wallet. Then you get to school and your friend wants to borrow the $1. So you're your best friend in the world, so you transfer the $1 from your wallet to your friend's wallet. Then your friend transfers it to a vending machine. Then the vending machine person comes to pick it up and transfers it to their cash box. Then the cash box gets transferred into a bank account, and so on and so on. Well, no matter how many times it's been transferred, that $1 is still only $1. It's not like when you put it to the vending machine, it transfers and becomes $2. That would be amazing, wouldn't it? Just like energy. In the Bill Nye video, when he's holding the bowling ball, he has a lot of energy stored as potential energy. Well, then he lets go, and it transfers into kinetic energy. But it's not going to hit him in the face when it comes back because the energy level is not going to grow. Energy is conserved. So that's one way that energy is like money, is it can be transferred. The second way is like energy, that it can be stored. And the third way is that the value stays the same if it is transferred. Number 6, explain what would happen to a heating curve of water if more heaters were added. So let's just take a look at a heating. Oh man, that's a bad one. Okay, if this is our heating curve, that's not much better. Okay, if this is our heating curve, this is temperature and this is time. Well, if we have more heaters added, basically, the rise of temperature is going to go faster. And so if it's going to go faster, that means it's going to take less time. But it's still going to go up to the same temperature. So let me just pretend that is there. So instead of being like that, we might see an increase like this. Then we see a shorter plateau here. Then we see an increase like this. Then we see a shorter plateau here. Unless we continue heating up, then this plateau just stays there. Because if we have water boiling on our hot plate, it's going to always stay at 100 degrees. So the key is that it's basically like we're taking this graph and we're squeezing it into a smaller time. So let's say that this takes 10 minutes. Well, if I use 2 heaters, then theoretically it should take about 5 minutes. So it'll be half the time. Number 7, explain what would happen to a heating curve of substance if there was more water. Okay, well, let's draw our heating curve again. If water, the melting point of ice is at 0 degrees Celsius, and the boiling point is at 100 degrees Celsius. If you add more water, these temperatures still are the same. Whether you have a gallon of water or a cup of water, the boiling point will be 100 degrees Celsius and the melting point will be 0 degrees Celsius. So now if you're adding more water, it's just going to take longer to heat up. So if this is our, let me see if I can do a duplicate. Actually, I'm just going to do them on the same graph, save some time. So let's say this is our original one, like so. Then if there is more water, it's going to take longer to get to the same plateau. And then that plateau is going to be longer, and then it'll take longer to heat up, and then it'll be at this plateau longer. So this graph is the more water, and this graph would be for the less water. Just think about this. If you have a small pot of water on your stove and a large pot of water on your stove, that small pot of water is going to heat up and boil quick. Here, let's say this is 5 minutes. If you have a big pot of water, it's going to take longer to get to boiling. Let's say this is 10 minutes. So the lines will still connect. The plateau is still going to be at 0 and 100. It's just that it's going to take longer.